Hi guys, in the last lecture we have discussed about the carbohydrates and we have seen some of the structures of the uh, carbohydrates. Uh, so in this weekend task I have given the structures for some of the oligosaccharides including the disaccharide, trisaccharide, tetrasaccharide, pentasaccharides and what we have discussed about that task. Uh, Several structures, cellular bios. These are the part of the assignment I have given it you people on the weekend. So these are the answer for that assignment. This is the structure for the cellular bios consisting of two glucose unit, but we can see it's a beta type of the linkage, beta 1,4 type of the linkage. First carbon of this glucose that is binded with linked together with this fourth number of the carbon. This is the cellobiose. It's a disaccharide. Then one of the point that I have given for the structure to you people, that is the beta gentibiose. Again, that is composed of the two glucose unit. You can see that two glucose units that are oriented in the pyranose form, and the linkage between these are the 1,6 type of the linkage. The first carbon that is linked with the sixth carbon of the second glucose unit. Similarly, there are some other structures. This is the sucrose. We have discussed this structure in the class already. We have discussed this structure consisting of one glucopyranose unit and other is the fructose in the furanose form. And we have discussed that have a 1-2 linkage. This is trihalose structure, and this again have a, you can see here, this is an inverted form. This is an inverted form, and just like that, I have told you about the sucrose that orient itself in at 180 degree. This one, the second glucose molecule. So that is the linkage, and then inverted in this condition. This is the lactose, composed of the lactose. This is the galactose and this is the glucose unit, and that have the beta type of the linkage, beta 1,4 type of the linkage. This is the alpha type of the linkage. This is again the beta type. Because why that is beta? Actually this is the in the inverted form. Actually this is the beta type of the linkage due to its inversion process. Then another disaccharide, that is the maltose, consisting of two glucose unit. Again, these are the two glucose unit and 1,4 alpha 1,4 type of the linkage. In isomaltose, 1,6 type of the linkage is there. So I hope you have practiced on this weekend all of this. And some other disaccharide, I give you the task to make the structure for these showing their linkages. So you can see sucrose, we have discussed about their lactulose that is composed of one galactose and the fructose unit, and you are well aware how to write the structures of this galactose and the fructose, and that have the beta type of the link, beta 1,4 type of the link. It's mean galactose first carbon and for fructose fourth carbon that are linked together. Then we talked about the lactose that is composed of galactose and the glucose. Again, 1,4 beta type linkage. Then maltose. So you have to make the structures for this during all of these 3 weeks. During that 3 weeks, all of these I have given you already, and this is already present on my website as well. So all of the structure you have to make on this. So then we are talking about the trisaccharide then. Trisaccharide mean that consists of 3 units. So in these are all the examples for the trisaccharides. Isomaltotriose, that is composed of 3 glucose units. The first and second glucose unit are linked together by alpha 1,6 type of the linkage, and the third glucose that is also linked towards 1,6 linkage. Uh, Another important one is the raffinose, that is composed of lactose, glucose, and fructose. This you know that this later part, that is actually the sucrose. Glucose and fructose, when that link together by 1,2 linkage, that is actually the sucrose, that is a table sugar. So the table sugar, when linked with the lactose through 1,6 linkage, that is forming the raffinose, and that is present in most of the uh, uh, fruits, vegetables, and especially beetroot, sugarcane. So that is very common, this raffinose, and that is the less sweeter part of that. This trisaccharide, that is the less sweet uh, source of the sugars. So these were all the assignment you have to do during your stay at your homes. Uh, Then in the previous lecture, we have talked about the nomenclature of the carbohydrates, chiral groups, and we have seen the structures. We have seen the Haworth type of the projection, Rosanoff type of the projection. We have seen the Fisher type of the projection. So these are some of the projection that is used for depicting the structures of the, especially the monosaccharide unit. We have practiced all of that. Aldo type of the sugars and the keto type of the sugar. So this is the isomers. That is actually the isomer D and L type of the isomer. One of the example I have given you earlier, that these are the mirror images with each other. So if you look at this one, this top one is the aldehyde group. Similar is the case with this one, and the H are oriented onto the right hand side. Later OH, later these H are on the right hand side, and the terminal for the ramenose, that is the CH3. In other structure, we have seen the CH2OH, the ramenose that can consist of the terminal CH3. And if we see that the D-ramenose and the difference between the D-ramenose and the L-ramenose, that is the mirror image, that is totally opposite to that one. So this is the example for the mirror image. If you look at this one, this is the glyceraldehyde structure. LD, aldo sugar, aldo terminal initiating point is that. Then OH on the right hand direction and H on the left hand direction, and CH2H on the terminal. So if you look at this in the mirror, because this is the D-glyceraldehyde. So if we look at in this mirror, all of these are in the opposite direction. This is in the opposite direction. This is in the opposite direction. So, so one of the concept for the mirror D and the L substances, that are the mirror images. So look at this example. The OH is oriented on this side, but on the mirror, as the mirror image, the OH is oriented on that side. Same is the case with here. So one thing we have discussed about how the Fisher projection, that can be described in the form of the Pyranose and the Furnose type of the structure. That is actually the Haworth. This is the Fisher projection. This is the Haworth projection. One thing we have discussed, that in normal condition, these substances that are arranged in different, that are available in different form. So that may be available into the furanose form. It may be available into pyranose form. So look at this one. This is the Fischer structure, straight chain structure. This is the fructose that is available in the furanose form, the alpha D fructofuranose and beta D fructofuranose. Both are these alpha and the beta. You know that these are due to the presence of anomeric carbon. So same is the case with the pyranose form. Either it's a alpha pyranose form, or either it's a beta pyranose form. So these are the for the fructose. These top one are the dominant forms. We have this, but for the glucose, if we are looking for the glucose structure, the pyranose form alpha pyranose and beta pyranose. These are the dominant type of the structures. So look at this one. This is the example for the glucose. That can be either present in the alpha form or beta form. And the same case for the D-glucose. This you can describe in this type of this structure. This is a straight chain structure. Sometimes that is available in the furanose forms. These are the both are the furanose form. Sometimes that is available in the pyranose form. This is the alpha pyranose form, and this is the beta pyranose form. This is the alpha type of the furanose form. This is the beta type of the furanose form. So these are the available forms in which these structures can be represented. Another example for the D-talose, similar is the case, that can be described in the straight chain structure, alpha furanose type form, beta furanose type form, alpha pyranose type form, beta pyranose type form. Same is the case with the ribose. You can describe it in the ribofuranose or ribopyranose form. That can be existed in alpha type structure or beta type structures. So this is the representation how the aldo sugar that is converted into the keto type of the sugar. You know, glucose is a aldo type of the sugar, but the fructose that is a keto type of the sugar. So that are you know that these are the isomers having the 180 molecular weight. So isomers mean having the same molecular weight but different structured form. So glucose and the fructose that are basically the isomers and that are interconvertible. These aldo sugars that can be converted into the keto sugar. So how what is the basic reaction for that? Uh, so look at this one. This is called as the anidiol type of the reaction. Anidiol type of the reaction. So look at this one. In the first instance, what is actually happening? This is the D-glucose molecule. As you know, this is the D-glucose. You are well aware how to draw the structure for the D-glucose molecule. So that is actually sharing the hydrogen from this end that is actually converting to that. So second hydrogen from the second carbon that is transferring onto the first. So that is making the trans-anidiol. And you can see here, this is a reaction that is actually the reversible. It's a reversible reaction. So after the formation of this trans-anidiol, the second step is removal of this hydrogen and shifting again towards the first carbon. So what is that? That is making a keto group. So look at this one. All of that is making a keto. So you know that the fructose, that is a keto sugar. So we can see the aldehyde group. This is the aldehyde group. Aldehyde group, how that is converting from this hydrogen and this hydrogen in two steps, that is moving towards the first anomeric carbon. So making a keto group automatically. So all the structure that is the same. So the fructose molecule that is developed. And how to convert this fructose? Fructose is a keto sugar that can be converted into the aldose sugar. That can be either converted into the glucose through these reversible reactions, or further that can be converted into the mannose. Again, it's a aldose sugar. Okay. So look at this one again. That is a transanediol reaction, and at that point, this is a cis-enediol type of the reaction. So this is the reverse process. The hydrogen that will be donated to the second carbon. Here we have seen the second carbon has donated the hydrogen to the first carbon. Here the first carbon that is donating the hydrogen to the second carbon. So look at this one in two steps, that is donating two hydrogens to that hydrogen to that one. So forming the molecule of the mannose. So I have told you earlier the first carbon that is called as the anomeric type of the carbon. This carbon here, this carbon, that is the anomeric type of the carbon. So when the ring structure is formed, that anomeric carbon that is involved in this type forming the, so this is actually removed. So that can be best described in the chair type of the structure we have discussed in the class. And I have told you that in case of the glucose, the dominant form are the pyranose form. Pyranoses are the dominant form. Pyranoses are the dominant form. About 38% is the alpha D. Same is the case. 38% is the beta D glucopyranose. So combining both these, 76%. And these are the very low amount furanose form in the case of the glucose. So you can, this is the end of this. We are concluding this lecture here, that we have discussed some of the disaccharide, oligosaccharides, monosaccharide structures, and revise some of the things that we have already discussed into the class. So we will close this lecture here. Thank you very much.